All right, this lesson is on adding vectors. We're starting on worksheet 2, side A. The first question says, add vector u plus v plus w. So we just added the x components and the y's, and we got negative 3, 6. This is now vector u plus v plus w in component form. But it says find its magnitude and direction. Who remembers from yesterday what that means we need to do? These little goofy symbols mean magnitude, and we need to do what? Negative 3 squared plus 6 squared. It's basically the distance from the origin to this point. Okay? So we're doing Pythagorean theorem in essence. 9 and 36, square root of 45. Does that sound right to anybody? 3 square roots of 5, or you could give me a decimal. I'm not, it doesn't say we have to be exact, so whichever. All right, anybody remember how we did direction? Inverse tangent of what? Okay, y over x, which in this case is inverse tangent of our resultant 6 over negative 3. We are working in degrees just because it makes more sense for the applications we're going to do in a minute. We get negative 63.4 degrees. Unfortunately, we're not always finished when we get that answer. We have to figure out what quadrant we're in. If we are at, from the origin, 3 to the left and up 6, our vector is here, okay, was negative 3 and up 6. Is that angle negative 63.4 degrees? No. The negative 63.4 is down here because inverse tangent is only defined in quadrants 1 and 4, so the calculator is kind of confused where we're at. So, anybody remember what we do to move it around? We just add 180. Basically, anytime you're in the wrong quadrant, if you add 180, you'll be in the right quadrant, okay? Yesterday we did a couple problems where we added 360, but that was to get a positive name. It didn't change the quadrant, it just gave us a positive name. So if we add 180 to this, we get what? 116.6. Thank you. I'm deaf. Okay, so this was the magnitude. And this is the direction or angle off the x-axis. Positive x-axis. Is it right?
Yeah.
Okay. Okay, just making sure I didn't do something silly. All right, moving on. Did everybody get that?
Yeah.
Everybody okay? Grant, you got what you want down there?
Yeah.
Okay. All right. This is a little bit harder. It's a fair amount harder, but it's not bad to understand, I don't think. I'm going to draw a very crooked line. I'm going to draw an XY coordinate plane, and we're going to pretend that we're sitting on one of those really fun little, I don't know, when I was in gym class, we used to have these little scooters. Did you ever do scooters in gym class? Okay. We're going to pretend we're sitting on a scooter at the origin, and then we're going to pull with some force on it and see what would happen. Okay? So if we're sitting on this scooter and we pull, I wish it had different numbers, but it says 30 pounds of force at an angle of 30 degrees, so we just got to be careful which is 30 and 30. But off the x-axis, we're going to pull 30 degrees above the x-axis here with 30 pounds of force. And that's vector u. Vector v is pulling with 50 pounds of force, so almost twice as long of a vector at negative 40 degrees. Okay, that's really crooked. Let me try again. I don't know. How's that look, guys? That look like it could be proportionally longer for 50 pounds, and negative 40 degrees. Okay, so what's going to happen if those two forces act on our scooter? Our scooter's going to go flying over here somewhere, right? And is it going to be above or below the x-axis, you think, when it stops? A little bit below, because it's pulling harder and further down, right? Sounds like a plan. Let's see what happens. We're going to write the components. I don't know, is that a good color? We're going to write, well, let's hear, write the components of this vector right here. How do you find the components? Yeah, we got to use sine and cosine. Do you remember we kind of drew this out yesterday and we talked about this is x and this is y? But do you remember what actually happened when we were done? We decided you took the length of the vector times the cosine of the angle, and that gave you the x coordinate, remember? The length of the vector times the sine gave you the y coordinate, and that was nothing new because we knew cosine went with x and sine went with y, right? Remember that part? All right, so for this vector, they're both 30, which is a little confusing. So when you write it out, make sure you write degrees by the second one, so you remember how I got that. It's 30 cosine of 30 degrees, comma, 30 sine of 30 degrees. All right, and components on this green one down here, anybody tell me that one? We do have to remember the negative, or we'd have to worry about putting a negative in somewhere, otherwise, because for the sine, it has to be going down. So the sine will turn out to be negative. If we just put the negative in, it will be fine. Okay, the resultant is when we add those two together. I'm going to write out the whole thing just because this is your notes. Normally you would just type it in. You don't have to write this out if you don't want to, but the resultant is going to be adding the x's together. So it's going to be 30 cosine of 30 degrees plus 50 cosine of negative 40 degrees. Okay, comma. Then you're going to add the y's together. 30 sine of 30 degrees plus 50 sine of negative 40 degrees. All right, and I left out the parentheses that time, but you still need them when you do it on your calculator. Okay. So 30 cosine of 30, close parenthesis, plus 50 cosine of negative 40. We added the x coordinates together. I got 64.3. Anybody else? Did I type something wrong?
No, it's
Okay, and then back here, 30 sine of 30, close parenthesis, plus 50 sine of negative 40, don't forget the negative, negative 17.1, anybody?
I got that too.
Thank you. All right. Is that at all what we thought? It's not making a lot of sense to us yet, but does it at least seem like it's going to be in the fourth quadrant? It's positive and a negative? Okay. That's the component form. That doesn't help us a whole lot. What we need to do is determine the magnitude and direction. Okay? How do we find the magnitude? Yeah, we got to do that whole square root of 64.3 plus 17.1 squared, because I'm lazy and don't put the negative, because then I'd have to have parentheses, but whatever you want to do. Oh, I forgot the squared on there. Sorry, I said it, I think, but I forgot to write it. What, did I type something wrong? I got 66.5 after I square rooted. Yes? Okay, that is the magnitude. Does it seem like, well, let's finish and then we'll draw our resultant in, but they're almost pulling in the same sort of direction, right? So it seems like the final fling was going to be more than 30 or 50 pounds of force. Okay, how do we do the direction thing? Inverse tangent of y over x, so negative 17.1 over 64.3. I get negative 14.9 degrees. Is that an okay answer? Is that off the x-axis, the right quadrant? Yes, it is. Okay, so I'm going to put in a vector that's negative 14.9 degrees below here. And it's more than twice this 30. I don't know if that looks right or not, but 66.5 pounds. Does that seem like what would happen to our scooter? Seems okay? All right. We need to keep in mind, is this realistic? Does it seem like this would happen? Because when we do these airplane questions in a minute and the wind is blowing the plane off course, it's got to make a little bit of sense or we did something wrong, okay? Everybody got everything we needed? All right. We are going to try this question. This is almost the same question. I just don't have this miles per hour for the wind right, so we're going to do the one off your worksheet. But let me read to you what it says, okay? It says an airplane is flying in the direction of 50 degrees with an airspeed of 300 miles per hour. If there is no wind, the course of the plane would be 50 degrees off of north. However, there is a 35 mile an hour wind from the direction of 120 degrees. I think yours says 30 mile an hour wind, doesn't it? So we'll use the, oh, it says 60 for the plane? Okay. All right, we're going to use the numbers on your worksheet, but it says the vectors are here. Find the course and ground speed of the plane. That is its speed and direction relative to the ground, taking in the effect of the wind. Okay, and we're going to use aerial navigation orientation. Okay, whenever it says bearing, we have to do some tricky business here. We are going to go here. Let me put in an extra slide here and talk for a second about this, what this means. I need to see my little icons under there. Okay, I'll fake it. I can't draw, but I'll pretend. If this is compass bearings, okay, this is north. When they say a bearing of, say, 20 degrees, they are telling you that that is 20 degrees off of north. It's always off north in a clockwise direction. Okay? So, where would a bearing, what quadrant, would a bearing of 200 degrees wind us up in? Would go 180 and 20 more. Everybody get it? Okay, it's off of north. Now when we use component form, we have to go off of the positive x-axis. So we're going to need some geometry skills here, some mad angle ability. All right, ready? This question, by the way, you're going to have these on your quiz, okay? I'm always, yeah, one. Not like 15 of them, no. But also on the quiz, I'm going to give you a hint of a drawing like this, okay? You're going to have to figure out all the angles, but at least I'm going to start you out with a little bit of something, okay? So that you don't draw this totally in the wrong quadrant, okay? This question says the airspeed of a plane is 300 miles per hour at a bearing of 60 degrees. Anybody know where that 60 degrees is going to go then? off of north, so it's this one. We can't use that angle for our component form. We need this angle. What is this angle? Everybody's okay that that makes a 90, right? So this is going to be our 30-degree angle for components, okay? All right. And the length of this vector is its magnitude, which is 300 miles per hour. All right, this is the hardest part for students when it says the wind is 30 miles per hour from a directional bearing of 120 degrees. Like my picture here. This means the wind is over here 120 degrees off of north. He's standing there blowing us on our plane this way. It's coming from that direction. It does not mean it's blowing the plane in that direction. It's actually blowing the plane over here. All right, so this is 120 degrees from there around to there. What does that mean this little angle in here is, guys? 30, right? Because 120 was 90 plus 30. You with me? Okay. Where's another 30 then? By vertical angles, that's 30. Okay, now I have 50 million colors on here, but I need this angle actually off the x-axis to do the magnitude of our wind. 150 is right. The wind is blowing the plane onto the wind is blowing, okay, at a measure of 150 degrees off the x. And its little length is what, 30 miles per hour? Okay, that says that that is 30 miles per hour long. All right, I'm going to erase a couple things I wrote there just because it's really confusing. All right, we're going to do what we did a minute ago. We're going to write down the components. I'm going to go over here and write them. If you want to write them by your vectors, that's fine. But the plane's components are what? What's the length of the plane's vector? 300. And the cosine of the angle off the x-axis, what was the angle off the x-axis for the plane? 30 degrees. And 300 sine of 30 degrees. This is how it will look on the quiz. I will give you blanks to write that because then I can follow your work and know what you did wrong so I can give you partial credit, okay? Then it will say wind, okay? What is the magnitude of the wind? Everybody should be able to get that right. It's right in the question. 30 miles per hour, right? Times the cosine of, this is where everybody goes wrong. What's the angle off the x-axis for the wind? 150. Okay, the resultant is when we add those together, okay? We're going to add the x's and get a resultant x value, and then we're going to add the y's and get a resultant y value. Can I not write that out? Do you understand what I'm saying when I'm saying that? We're going to type 300 cosine of 30, close parenthesis, plus 30 cosine of 150, close parenthesis, and we get what? Anybody else get 233.8? Yes. Okay. Now we're going to add the y's. 300 sine of 30 plus 30 sine of 150. Closing your parentheses in the right spot. Please be doing this because it's so easy to type sine instead of cosine or 300 instead of 30, and we need to figure out what you're doing wrong. Yes?
It's cool if I do it separate, right?
What do you
Like, I
mean
don't type
separate?
the whole thing in.
Yes, yeah. You might get off a tiny decimal. I got 165. If you want to change these to decimals first, that's okay. I just write it all out and then add them together on the calculator. Did someone else get 165? Okay. We need the magnitude and directional bearing of the plane. So we need to do magnitude of this. Anybody get an answer? 286.2 miles per hour. Okay. Inverse tangent of 165 over 233.8. .2 degrees. Okay. What we just found is that the plane is actually going 35 degrees off of the x-axis. Whoops, and I drew it too long. And it's only getting 286 miles per hour. Did someone else get 35.2? I did that part right? Okay. Does it make sense that the wind pushing back against it slowed it down a little bit and pushed it a little back towards north? If this was what the wind was doing to the plane, right here where my arrow is, does it make sense that it pushed it a little bit back towards north? Okay. We need to finish the question with a bearing. It's not a bearing right now. Well, yeah. If we could do towards north off of east or whatever, they want us to do a directional bearing. They want off of north. That's it. So just tell me off of north. What is this angle? If this is 35.2, what's this one, guys? How do you find that? 90 minus 35.2. Okay. It's making 286.2 miles per hour. And it's at 54.8 degrees off north. They will just call that a directional bearing. Okay. I always write off north so I remind myself. And on the answer, it will say blank off north to remind you that you need to fix it to be off north, okay? What did we do here? Okay, so it was originally trying to fly 60 degrees off north, but it wound up getting pushed back to 54.8. Make sense?
I have a question.
Yes.
Okay, so you have the one. The original one going at the whatever.
The red one?
Yes.
Okay.
And then if you put so never mind.
Okay. We'll do another one. See, if you need me to stop at some point, explain something better, let me know. We're going to do one where the wind is not blowing from, it's blowing toward. Toward is easier. Yes. Sorry, Zach, I couldn't see you through there.
How do you know that 35.2 is like from
When we do inverse tangent, okay, the component form is always off of x, and these were both positive, so I knew I needed to be in the first quadrant. It always is telling us, when we do inverse tangent, it's always telling us off the positive x-axis. Good question. All right. Okay, guys, we ready to try again? This is how the question would look on the quiz. So see what you can label. It would be started like this for you, okay? I just found that if I didn't give a little bit of a hint on the quiz, about half the class didn't even try it. If I give you this much of a hint, some of you will try it, yes? How long is this red one gonna be? Okay. 100 degrees is off of north. So what is this in here? It is 10 degrees. We need to say negative 10. Otherwise, it will not give us the correct sign on the y value. We need it to be a negative. So the plane components are going to be 400 cosine of negative 10 and 400 sine of negative 10. See, it wasn't that hard. All right, what about the wind? This time it's blowing the plane toward a bearing of 135. Toward is easier because you don't have to reverse it, okay? The wind is over here. Here's Mr. Wind, and he's blowing it this way. 45 miles per hour. And off of north, the bearing it's pushing it is 135. How would we find off the x-axis right there? Take off the 90 up there and we'd have negative 45. And it's negative because it's below the x-axis, right? So what are the components for the wind? 45 cosine of negative 45 degrees. Add the x's, add the y's, and get the resultant. Can everybody do that and see what you get? Anybody get in numbers there? That is what I got as well, Bryce. Anybody else having trouble?
Oh, no.
If you're not getting that, let me know so I can come and see what's going on. Did you have a question, Zach, or you're just... Okay, that's all good then. Okay. Bromance gone bad, is that what you're saying? All right, now what? That's kind of the easy part, but we didn't find the actual answer yet. What do we have to do now? The magnitude and direction. That was cruel. Anybody get this? Okay, that doesn't seem so bad, right? Okay, now what? Okay, magnitude's worth a lot of points. Now we gotta find the directional bearing, and this is where it gets hairy. We gotta do inverse tangent. Shh, guys, please. Does negative 13.4 seem right, that the plane would actually be going? Okay. Right, 13.4 degrees off of there. And 437.6 miles per hour. I think we're good, except what? Yep, we gotta put it off north. Should be 103.4 because our directional bearing has to go from here plus another 13.4 degrees, right? So this was 13.4, so the whole bearing was 90 plus 13.4, 103.4 degrees off north. Are we having fun yet?
I don't like the.
Okay. Now we're going to do the same question 2 different ways. Because we're going to talk about how they do them in physics. And some of you might like this way better. We're going to use what's called tip to tail. Yeah. And when I've taught it one way and you have all that stuff on the drawing, it's very hard to go back and show tip to tail. That's why I have this one down here twice so that we can show it both ways, okay? If you like the tip to tail, you can do that. It's okay. Tip to tail uses law of cosines and law of sines, okay? All right. We're going to do this one the way I've been teaching it. There are two, here's our scooter right here, okay? There are two forces acting. Vector A is 48 pounds of force, pretend that says pounds. It says right here, okay, magnitude is 48 pounds. Vector A, length 48. I made a little chart this time just so we can keep it all straight. All right, what is vector A's angle off the x-axis? 72 degrees. Okay. Vector B is over here, and it says right here it's 32 pounds. So its length is 32. But the only angle we're given about B is this 26 degrees. Are we going to put 26 degrees here? You actually could, but then you'd have to change the sign on your x coordinate because it's going left. So it's easier just to always do off the positive x-axis, in my mind anyway. How far is this? 180 minus 26, which is what? 154 degrees. Now, you can type these in if you want. I'm just going to write them. This is going to be 32 cosine of 154 and 32 sine of 154. And this is going to be 48. Oh, I should be doing that in green, huh? Length times cosine of the angle, length times sine of the angle. Okay, now I'm going to add these two and get a number. And I'm going to add these two and get a number. Can I add the 54 and 72 and get a number? Can I add the 48 and 32 and get a number? I can, but is it going to be the magnitude and length of the vectors? No. We have to do this first, okay? Find the components, and then we'll be able to go backwards to find the magnitude and length. Or magnitude and angle. Okay, anybody already typed this? I got a negative 13.9. Did I do something wrong?
Yeah, I got negative 14.
I got the same thing.
Okay.
And then I got 59.
71.5? What'd you get on the other one, guys?
59.7.
Yes.
Oh, oh, I did 54 instead of 154. No, you're good. I'm wrong. 59.7? Okay. Now what? Now we do Pythagorean theorem of those two numbers. And that'll give us the length. Shh, guys, you're making this hard to hear on the video. I need you to not be so chatty. Anybody get a length? Okay, even on my picture, I made it look longer than either of the other two, right? It's 61.3 pounds. And then how do we find the resultant angle, the direction? (59.7) divided by negative 13.9. Okay, this is a weird one. Negative 76.9 degrees. It thinks we're down here. Are we going to go in that direction? Remember, our components were negative positive, so they are in quadrant 2 over here. Okay? Because they were negative positive, we were in quadrant 2. So how do we make this be in quadrant 2? Add 180. Now that's not a directional bearing. It's off of the x, but it didn't ask for a direction on this. Okay. The directional bearing would be a mess. Okay, the directional bearing would be all the way around to there.
It can't be negative.
I don't think so.
So it'd be 360 minus 103.1?
No.
Or 160 minus, I mean, no, 360 minus 76.9.
Yes. Yes. If we took 90 off of this, we'd have, what, 13.1? That means this angle in here is 13.1, so if it was a directional bearing, it would be 360 minus 13.1. There's other ways you can get there, but that's the one that makes the most sense to me. Okay, we're not doing a bearing question, so let's not get sidetracked here. All right, we're going to do this question again, and we're going to use what physics calls the tip-to-tail method, or tail-to-tip. Which way does, how do you say it in physics?
Tip.
Tip-to-tail? Okay, tip-to-tail. Tip-to-tail. So, what they do, ready? Okay. I drew the same picture. But what you have to do is take the vector you are adding, either one really, I took vector B, and slit it up until it starts at the end of vector A here. So it's going this way and this way. Now, to be able to do that, equivalent vectors, remember, have to be parallel. Okay? So this vector, remember in geometry, use little arrows to show, little arrowheads to show they were parallel? Those are parallel. Everybody okay? Yes? Maybe?
Yeah.
Okay. We need to find some angles. How long is vector A? First, that's not an angle, but how long is vector A? 48. How long is vector B up here? Okay. This is where it gets kind of weird. We are gonna have to find this angle in here between these two so that we can use law of cosines. Your geometry brain should tell you what this angle is. Watch right here, guys. What letter am I drawing? Zach? That's a Z for Zach, right? If this is 72 degrees, what's this angle right there? Remember your alternate interior angles from geometry. Now, does anybody know what this angle is right up here? No. It's not 18. Where did that vector come from? We slid this vector, right? This was 26 degrees above horizontal, and we slid it up here. So this should be 26 degrees above horizontal right there. All right, so what is the angle in between these two vectors? 98 degrees. We got to add all that together. That is 98 degree angle. If I go over here, don't do that. If I go over here and I redraw that triangle real quick, it says this is 48, this is 32, and this is 98 degrees. And you need to find this side over here. Can you do law of cosines to find that? Okay. X squared equals 32 squared plus 48 squared minus what?
2.
Start typing. It's a miracle. Is that not the same number we had on the last one? 61.3 pounds? Yes? Okay. Now we need to find an angle. The angle, yeah, I don't like this way, but the angle we need to find, is all of this. So what we're going to find is theta right in here. Go back over to this triangle. You just told me this is 61.3. Okay, can I not write that in there? 61.3 is that side, okay? Can we now use law of what? Sines to find that angle down there. So we're going to have the sine of something is across from 32 in the same way the sine of 98 degrees is across from 61.3. So we're going to do sine of 98, close parenthesis, times 32, divided by 61.3. We get an ugly decimal, and then we have to do what? Second sine of that. I got 31.1 degrees. Okay, that's in here in the triangle. 31.1 degrees. So from the x-axis around to there is how much? $72 plus 31.1. Do you see that? This was 72 to the purple line, and that's another 31.1. 72 plus 31.1 is 103.1 degrees. Is that what we had?
Yeah, I don't like that word.
All right.
I'm gonna be crying the whole time.
There's like 7 over right here.